In today we will see the 14th session. So again the problems on thin cylindrical cells. So in the previous sessions I have explained what is the definition of thin cylindrical cells and some problems on thin cylindrical cells. So thin cylindrical cells, the mainly the failure of thin cylindrical cells, how the failure of thin cylindrical takes place. So based on the failures, so we have made two types of stresses are induced in the thin cylindrical cells. So one is of circumferential stress, it is also called as a hoop stress, and longitudinal stress, and respective formulas we have seen, and also we have solved some problems on the thin cylindrical cells. And in the previous session, so we have also gone through the design of thin cylindrical cells. Design of thin cylindrical cells means we need to find out the how much diameter is required to design for a given the maximum stress, and also the thickness, and sometimes we have to derive the internal pressure also. So this is what the design of thin cylindrical cells, and today also we will solve some of the problems on this. So now the problem here given is a water means 80 centimeter diameter contains water at a pressure head of 100 meter. If the weight density of water is 9810 Newton per meter cube, find the thickness of the metal required for the water mains. Given the permissible stress is 20 Newton per mm square. So this was the problem. So write the given what is given in the problem. So pressure head of the water, that is H, is equal to 100 meter. So it is given in the problem, and a diameter is given, that is 80 centimeter. So convert it into a mm, so it is 800 mm. So weight density of water, that is W, is 9810 Newton per meter cube. Permissible stress is equal to the circumferential stress, that is called as sigma C. So that is sigma C is 20 Newton per mm square. So pressure of the water inside the water main, so it is given by P. So P is equal to W into H. So the W is weight and H is the height. So its weight is given as 9810 Newton per meter cube into 100. So it is weight density. Now W is not weight, it is a weighted density. So it is 9810 into 100. So this becomes 9,81,000 Newton per meter square. So this into 10 to the power of 6 will, you can write it in Newton per mm square. So it is 0.981 Newton per mm square. So this is the internal pressure. So from this internal pressure, again from using the circumferential stress formula, so this is a sigma C. Sigma C is equal to PD by 2T. Then substitute all the values to find out thickness. Now he is asking you to find out the thickness. So T is equal to PD by 2 sigma C. Again this is, so substitute all the values. So P is internal pressure, just now you have calculated. Substitute here, it is 0.981 into 800 divided by 2 into 20. So that is equal to 20 mm. Then so that's the thickness. The next problem is a boiler shell is to be made of 15 mm thick plate having a limiting tensile stress 120 Newton per mm square. If the efficiency of the longitudinal and circumferential joints are 70% and 30% respectively. So determine first one, the maximum permissible diameter of the shell for an internal pressure of 2 Newton per mm square, and second one is permissible intensity of internal pressure when the shell diameter is 1.5 meter. So the two cases he has given, and the problem he has separately given the efficiencies of the rivets in longitudinal direction as well as in circumferential direction, right? So here, so taking the first case, so before taking the first case, write down what is the given data in the problem. So the T is equal to 15 mm. So thickness is given in the problem. Limiting tensile stress is 120 Newton per mm square. N, this is neta L, that is efficiency in longitudinal direction, that is rivet efficiency. This is in longitudinal direction, that is 70%. So we can write it as 0.7. So this is a circumferential efficiency of the rivets. So neta C, we can write it as 30%. So that is equal to 0.3. So first case, the maximum permissible diameter for an internal pressure P is equal to 2 Newton per mm square. So he is asking you to find out the maximum permissible diameter. So when the internal pressure is given as 2 Newton per mm square. So he has given the explanation now here. The boiler shell should be designed for the limiting tensile stress of 120 Newton per mm square. This is given in the problem. So you need to design the boiler which can withstand the tensile stress, that the limiting tensile stress of 120 Newton per mm square. So the first, consider the limiting tensile stress as circumferential stress and then as longitudinal stress. The minimum diameter of the two case will satisfy the condition. So now the limiting tensile stress ಈ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ 120 ನ್ಯೂಟನ್ ಪರ್ ಎಮ್ ಸ್ಕ್ವೇರ್ ಕೊಟ್ಟಿದ್ದಾನೆ. ಸೊ ಅದಕ್ಕೆ 120 ನ್ಯೂಟನ್ ಪರ್ ಎಮ್ ಸ್ಕ್ವೇರ್ ಲಿಮಿಟಿಂಗ್ ಟೆನ್ಸೈಲ್ ಸ್ಟ್ರೆಸ್ ಅನ್ನ first time you can consider it as circumferential stress once, and next time you consider it as longitudinal stress. So in the both the cases you find out the diameter. ಸೊ ಡಯಾಮೀಟರ್ನ ಕಂಡುಹಿಡಬೇಕು. ಒಂದು ಸರಿ 120 ನ್ಯೂಟನ್ ಪರ್ ಎಮ್ ಸ್ಕ್ವೇರ್ನ ಸರ್ಕಂಫರೆನ್ಷಿಯಲ್ ಸ್ಟ್ರೆಸ್ ಅಂತ ತಗೋಬೇಕು, ಆವಾಗ ಡಯಾಮೀಟರ್ ಕಂಡುಹಿಡಬೇಕು. ನೆಕ್ಸ್ಟ್ ಟೈಮ್ ಅದೇ 120 ನ್ಯೂಟನ್ ಪರ್ ಎಮ್ ಸ್ಕ್ವೇರ್ನ ಲಾಂಗಿಟ್ಯೂಡಿನಲ್ ಸ್ಟ್ರೆಸ್ ಅಂತ ತಗೋಬೇಕು, ಮತ್ತೆ ಡಯಾಮೀಟರ್ ಕಂಡುಹಿಡಬೇಕು. ಸೊ ಎರಡು ಡಯಾಮೀಟರ್ ಬರುತ್ತೆ, ಅದರಲ್ಲಿ ಯಾವುದು ಮಿನಿಮಮ್ ಇರುತ್ತೋ ಸೊ ದ್ಯಾಟ್ ಯು ಕ್ಯಾನ್ ಸೆಲೆಕ್ಟ್ ಆಸ್ ದ ಡಯಾಮೀಟರ್, ಸೊ ವಿಚ್ ವಿಲ್ ಸ್ಯಾಟಿಸ್ಫೈ ದ ಕಂಡೀಷನ್, ರೈಟ್? ಸೊ ನೌ considering the circumferential tensile stress, that is sigma c is equal to PD by 2T. So this is a efficiency in the longitudinal direction. I told you whenever you are using the circumferential stress, then you have to take the longitudinal efficiency reverse. ಇಲ್ಲಿ sigma c ತಗೊಂಡಾಗ ಇಲ್ಲಿ L ತಗೋಬೇಕು, ನೀಟಾ L ತಗೋತೀರಿ. ಇಲ್ಲಿ sigma L ತಗೊಂಡಾಗ ಇಲ್ಲಿ ನೀಟಾ c ತಗೋತೀರಿ. So now substitute all the values, only the D is only the unknown here. So 120 is equal to 2 into D divided by 2 into 0.7 into 15. 0.7 is for the rivet efficiency in the longitudinal direction. So substitute all the values. So bring D on the left hand side. So bring all the values on the right hand sides. Then you will, or then the answer will be 1260 mm. So after solving you will get this much as the diameter when 120 Newton per mm square is considered as the circumferential stress. So the same 120 Newton per mm square, if you consider it as the longitudinal stress, then what would be the diameter? So substitute here sigma L. This is sigma L is equal to P into D divided by 4 into neta C into T. It is 40. PD by 40 into neta C, that is. Right? Substitute all the values again. So bring D on the left hand side. So all the values on the right hand side. Once again you solve this. So you will get it 1080 mm. So in these two, which is the minimum diameter now? So 1080 was the minimum diameter. So you can now select that as the diameter for your design. So from the above, the maximum permissible diameter is lesser of above two values, that is D is equal to 1080 mm. Right? This is the first case. So D is 1080 mm is the first case. In same problem, second case he has given, that is permissible intensity of internal pressure when the shell diameter is 1.5 meter. So in the first case he was given the permissible that is the internal pressure ಕೊಟ್ಟಿದ್ದ, diameter ನ ಕಂಡುಹಿಡಿರಿ ಅಂತ ಕೇಳಿದ್ದ. ಸೆಕೆಂಡ್ ಕೇಸ್ ಅಲ್ಲಿ diameter ಕೊಟ್ಟಿದ್ದಾನೆ, internal pressure ಕೇಳ್ತಾ ಇದ್ದಾನೆ, right? So in the second case also you need to consider again two cases. One is for circumferential stress and one more is for longitudinal stress again. So D is given as 1.5 meters, so it means it is 1500 mm. So the circumferential stress taking sigma C as 120 Newton per mm square, because it is given as limiting tensile stress, right? So again substitute all the values here. Sigma C PD, it is 120 is sigma C is PD by 2T. Now you have taken again neta L, because it is the efficiency of the longitudinal rivets in the longitudinal direction. So here sigma C ittandre neta L bartade. So substitute 120 is equal to P into 1500 divided by 2 into 0.7 into 15. So now the bring P on the left hand side, all the values on the right hand side. So the answer will be 1.68 Newton per mm square, right? So in the second case again consider longitudinal stress now taking sigma L. as 120 Newton per mm square now. So now sigma L, you know the formula, PD by 4T. The efficiency is given in the problem. So neta C you have to take. Neta C is efficiency of the rivets in the circumferential direction. If you are calculating sigma L in the longitudinal direction, at the denominator you have to take the efficiency of the rivets in the circumferential direction. So the substitute all the values. So it is 120 is equal to P into 1500 divided by 4 into 0.3 into 15, right? So bring P on the left hand side, all the values on the right hand side, then solve this. After solving you will get it 1.44 Newton per mm square. From the above, the maximum permissible internal pressure is lesser of above two values, that is 1.44 Newton per mm square was the answer. This is the answer. So now consider here 1.68 is there. So here 1.44 is there, which is the minimum value of both the two. That is your final answer. Even in the diameter also, which is the minimum diameter out of two stresses, then that is the answer. Now here also, out of the two pressures, then which is the minimum value that you need to select for the design. So in this case, the minimum value is 1.44 Newton per mm square. So we are selecting P is equal to 1.44 Newton per mm square is your final answer in the second case. So the next problem is a cylinder of thickness 1.5 centimeter has to withstand the maximum internal pressure of 1.5 Newton per mm square. If the limited tensile stress in the material of the cylinder is 300 Newton per mm square, factor of safety 3.0 and joint efficiency 80%, determine the diameter of the cylinder. He is asking you to find out the diameter of the cylinder, but here he has given joint efficiency 80%, right? He is asking 80% of the joint efficiency, right? So read it once again. A cylinder of thickness 1.5 centimeter has to withstand the maximum internal pressure of 1.5 Newton per mm square if the limit tensile stress in the material of the cylinder is 300 Newton per mm square, factor of safety is 3 and joint efficiency is 80%. Determine the diameter of the cylinder. So now take T, write the given data. T is 1.5 centimeter, that is 15 mm. P is 1.5 Newton per mm square. So the ultimate tensile stress given is 300 Newton per mm square and factor of safety is also given as 3. First you find out the working stress or safe stress. So that is sigma L now. So you will get it ultimate tensile stress by factor of safety. You know this formula in the beginning of this unit 1. So that is working stress. This is also called as the safe stress or it is design stress. To find out this, the ultimate tensile stress by factor of safety, so that is 300 by 3, so that is 100 Newton per mm square. So this 100 Newton per mm square, now I am considering this as the stress in the circumferential direction. So now joint efficiency means the efficiency of longitudinal joint. So it's given that joint efficiency means efficiency of longitudinal joint. So that efficiency is given as 80%. It means it is 0.8. It is 0.8. So now sigma C, this is sigma C is equal to PD by 2T. So it is given in the problem as efficiency. Also take that efficiency in the longitudinal direction. So PD by 2 neta L into T. Substitute all the values. So this is sigma C is 100. This is equal to 1.5 into D. So divided by 2 into 0.8 into 15. So bring D on the left hand side and all the values on the right hand side. So solve this, you will get it 1600 mm is the diameter. So thank you. That is end of your session 14 and also the end of this unit 1.